This lecture covers the last 2 or 3 sections of Chapter 11, and the main thing we're going to talk about, 3 of them are pretty simple concepts. Understanding the odds in favor versus odds against. So instead of talking about probability, we're going to talk about odds and the way those two relate. And then we're going to talk about conditional probability, and we'll learn about the complement rules of probability. And then the one that's a little bit trickier that I'll save for last are when we have to find probability about events that are not mutually exclusive. So let's get started. The book's definition for odds in favor, or to go from probability to odds, is given here, and you can see that to find odds in favor of an event happening, you find the probability of the event happening and divide it by the probability of the event not happening, and that is the odds in favor. And then it's a reverse of that for odds against. Now, I like to teach it a slightly different way, but I'd encourage you to read the book and read through their definition and their examples, and let me show you the way that I like to teach it that I think might be a little simpler for you, and then you decide what you like better. Okay, to find odds in favor, find the probability first, and then from that probability just simply put the numerator as a ratio to the denominator minus the numerator. So what are the odds in favor? We're going down here. What are the odds in favor of rolling a die and having the result as a 5? So first, what I said to do is first just do what we've been doing this entire chapter. First, find the probability of rolling a 5. Well, there's 6 possibilities, or 6 numbers in the sample space. When you roll a die, it's going to be a 1, 2, 3, 4, 5, or 6. And there's only one way of rolling a 5. So the probability of rolling a 5 is 1 out of 6, or 1/6. Now, to change that to the odds in favor, you just simply put the numerator, the top number, which is a 1, as a ratio to the bottom, or the denominator, minus the numerator. So let's take the 6 minus 1 and we get 5. So that's how easy it is to do odds in favor. The odds in favor of rolling a die and having the result be a 5 is 1 to 5. So what are the odds against rolling a die and having the results be a 5? It's simply this in reverse order. Just reverse the numbers. So it's 5 to 1. So once you know the probability, once again to find the odds in favor, it's just this top number, 2, which is a ratio, the bottom number minus the top number. That's where the 5 came from. Okay, let's do another example to make sure you got that down. Let's find, and this just repeats what I taught you on the previous page. What are the odds in favor of spinning a blue star? Okay, well, let's first find the probability of spinning a blue star. There's 1, 2, there's 3 blue stars. There's 8 total figures there, so the probability of spinning a star is 3 out of 8. So what are the odds in favor of spinning the blue star? It's simply 3 to 5. The 3 is our top number, and this 5 came from 8 minus 3, the bottom minus the top. So what are the odds against spinning a blue star? It's 5 to 3. For any of you that have seen horse races on TV, or have taken part in horse races, they do odds against when you do horse races. So if you see that some horse has 7 to 2 odds, that's 7 to 2 against the horse winning. And then naturally, then if you can go from probability to odds, it's really easy to do odds to probability. You just do the reverse of what we just learned. So let's say the odds in favor are 3 to 2, then the probability is 3/5. Remember, this 3 is the top number, and then this 2 came from taking the bottom minus the top, right? The 5 minus the 3 gave us that 2. So what we do here is add this 3 and 2 together to get this 5. So if I said something like odds in favor of rolling an even number on a die. Okay, what's the odds in favor of rolling an even number on a die? Well, it's 3 to 3, or 1 to 1 if you reduced it. Okay, what's the probability of rolling an even number on a die? It's 3, 6. This is our top number. Add these together to get our bottom number. So that's just doing the reverse of what we just learned. Instead of going probability to odds, we're going odds to probability. Okay, conditional probability is very, very simple. It's when you say something like this: what's the probability of this happening given that happened? So here's an example down here. What's the okay, a letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome is a letter that precedes H. So here's how that is written. What's the probability of the letter being a vowel? And this slash here means given that the letter precedes H. Well, the letters before H in an alphabet are A, B, C, D, E, F, and G. So what is the probability of selecting a vowel? Well, there's 2 vowels given the letter precedes H. There's a total of 1, 2, 3, 4, 5, 6, 7 letters. So the probability of would equal 2 7s. Here's another example. Find the probability of getting a heart given that the card you were dealt is a red card. So the way you'd write that is the probability of getting a heart given that the card you were dealt is a red card. Well, I bet you agree that half the red cards in a deck are hearts, so it'd be 1/2. If you don't want to jump to it that quickly, do you agree with this? We know that we're choosing from the red cards. There's 26 red cards in a deck. 13 of them are hearts. So whether you said 1/2 or 13 out of 26, you're correct. And this up here at the very top of the page gives a definition of conditional probability, and that's how you denote it, just like we did in our examples. I think I have another one here. Yeah. So when you read this right here, that means find the probability of spinning a star given that what we spin is a red. Well, let's take a look at it. If we're given that we spin a red, it means it landed here, here, or here, right? And we want to know what's the probability of it being a star given that we spun a red. So the answer to that would be the probability of spinning a star given that it's a red would be 1/3, because only one of those 3 red figures is a star. Now this is the reverse of that. Find the probability of spinning a red given that you spun a star. Well, that means we either spun this, 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 or this, because it says we spun a star, right? So find the probability of it being a red if you spun a star. Well, only one of those 4 are red. So the probability of spinning a red given that we spin a star is 1/4. And once again, that is called conditional probability. Okay, the third thing we're learning today, and it's another easy one, is the complement rules of probability, and this is pretty much common sense. Probability, here we go. The probability that an event E will not occur is equal to 1 minus the probability that it will occur. So, so to find the probability of not E, then you take 1 minus the probability of E happening. So roll a die and find the probability of not rolling a 2. Well, we know that if we rolled a die, the probability of rolling a 2 is 1/6, right? So the probability of not rolling a 2 is 1 minus 1/6. That's the same as 6/6 minus 1/6, right? 1 is the same as 6/6. 6/6 minus 1/6 is 5/6. Now, we kind of knew through common sense that the probability of not rolling a 2 would be 5 out of 6, because there's 5 numbers on a die that are not a 2, right? Now let's do another one. Draw 1 ace from a deck. No, I'm sorry. Draw 1 card from a deck and find the probability of not drawing an ace. Well, let's first find the probability of drawing an ace. The probability of drawing an ace is 4 out of 52, which reduces to 1/13, because there's 4 aces out of 52 cards, right? And that we divide both of those by 4 to get 1/13. So the probability of drawing an ace is 1 out of 13. So the probability of not drawing an ace is 1 minus 1/13. And you can think of that as 13/13 minus 1/13, which gives us 12 out of 13. And that's called the complement rules of probability. Well, one more example on that. If you spin the spinner once, what's the probability of not spinning a diamond? Well, common sense shows us there are 3 diamonds here, which means 5 of them are not diamonds, so the probability of it not being a diamond is 5 out of 8. If we want to use the definition we just learned, we knew that the probability of spinning a diamond is 3 out of 8, so we take 1 minus 3/8 to get 8/8 minus 3/8, which is 5/8. That's the other way to get 5/8 for that answer. Okay, we still have about 4 minutes, and I'm glad, because the last thing I'm going to teach you is a slightly trickier. We have to understand what mutually exclusive means. Are these events mutually exclusive or not mutually exclusive? When drawing one card from a deck of cards, find the probability of the card being black or being a diamond. Well, those are exclusive of each other because there's no black card that's a diamond, so you can do that problem really easy. It's simply the probability of black or diamond would just be the probability of black plus probability of being a diamond, because they have nothing to do with each other. There's no diamonds that are black. Okay, but if you read the next one, when drawing one card from a deck of cards, finding the probability of the card being red or being an ace. Well, aren't there some aces that are red? So that complicates the problem a little bit. So I'm going to teach you, and those are called not mutually exclusive. So I'll teach you how to do problems that are not mutually exclusive. In fact, I think this one might have came from the book. Draw one card from the deck. Find the probability of picking a face card or a diamond. Well, what you do is draw a Venn diagram. Here's our here's our diamonds. Here's our face cards. Well, we know there's 13 diamonds in the deck, but I don't write down 13 here. I write 10 here and 3 here because 3 of those diamonds are face cards. And there's a total of 12 face cards in the deck, but I put a 9 here and that 3 goes there because look at this 9 added with this 3 gives us our 12 face cards. This 10 added with this 3 gives us our 13 diamonds, right? Now, if you add those up, 10 plus 3 is 13 plus 9 is 22, right? That means there's 30 cards left out here that are neither. That they're not diamonds or face cards. And that takes care of the entire deck of cards. So, find the probability of picking a face card or a diamond. So the probability of a face card or diamond is, all you do is add this up. 10 plus 3 is 13 plus 9 is 22, so it's 22 out of 52, which reduces to 11 out of 26. Now, if you didn't like that example, let's say that we had 22 students in our class, and let's say 14 had cars and 9 had bikes. 6 had both. Well, I don't know why all of a sudden that came across. So, and I'm about out of time, so we're going to ignore that mess, and here we go. We're going to make a Venn diagram. Okay? These are people with cars, and these are people with bikes, and the people that had cars, there was 14, but 6 had both, so we had 8 and 6 adds up to 14. 9 had bikes, so we have 3 here. So here's the 14 people that had cars, here's the 9 people that had bikes, and notice there's 6 that had both together. So what would be the probability of a person choosing had a bike or a car? Well, there's 8 plus 6 plus 3. 8 plus 6 plus 3 is 17, so it's 17 out of 22. I wish I had a couple more seconds to go over that a little bit slower, but I don't.